Have you ever wanted to explore what's beneath the waves? Then look no further, as I'd like to showcase my Submersible ROV Arduino project. The main objective is to design an aquatic vessel called an ROV that can document videos while being safely operated from a boat or shore. The vessel is controlled by two joysticks that control two brushless motors via an H-bridge. A photoresistor allows visual of the ROV during dark environments, and a DH-22 sensor warns when humidity reaches dangerous levels for components inside. Here, this showcases the three sensor inputs, as well as the signal conditioning, microcontroller, and the corresponding output. This diagram outlines the various connections used for the three sensors and mechanical components, like the H-bridge, rocker switch, and battery. The following scroll of code also controls the signal input and its corresponding output. For example, if the light levels are too low, an if statement will turn on its corresponding LED. To power these motors, we use a 7.4 volt battery as opposed to the 5 volts provided by the Arduino. As we move the joysticks forward, each corresponding thruster propels forward. Since these joysticks are two-axis, they allow movement both forward and backward, allowing for 360 degrees of movement. When light levels are too low, the photoresistor will allow the green LED to activate. As you can see, brightness is sufficient, but when covered, the light will activate. When humidity levels are too high, the temp sensor will allow the red LED to activate. As you see, humidity is dry, but when in a hot, moist environment, the light will activate. Now this is the functional unit working together. A tether cable allows for a 60-foot range, while the mounted camera allows for live recording in the underwater environments. For next steps, I would like to integrate a ballast system to allow the vessel to traverse up and down without the use of external weights. This could be done by adding a component like a ballast tank, a syringe perhaps. Additionally, outer sensors could be integrated to collect additional data, such as an ultrasonic sensor to detect depth and a pressure sensor for the integrity of the ROV. Thank you for your attention, and hopefully you learned something cool. If you didn't learn anything, hopefully you at least found something cool in this video.